So this review session is on limits. So the first problem we're going to look at is number 2. If you will look at your formula sheet. Oh, okay, sorry. Okay, so let's go back and do number 1. But have your formula sheet out because we're going to need him in a second. So if I'm taking the limit as we approach infinity, you really just need to look at your highest powers. So I'm going to look at this term and this term, because everybody else is sort of insignificant compared to him. So if I look at what I have left, now as x goes to infinity, what's happening to the top and the bottom? It's getting bigger. Everybody agree with that? Okay, who's getting bigger faster? The bottom. So if the bottom is getting bigger faster than the top, where are we headed? Beautiful. 0. Good. Very good. Okay, now number 2, look at your formula sheet. Do you see? Oh, that's an H. Y'all see this guy? Do you remember the day I first taught you this and we found derivatives using this guy and it was crazy? And then the next day I said, oh yeah, there are these rules. Y'all remember that? So this you need, because you need to see, do you see how number 2 kind of fits him? If this is the definition of a derivative, you're going to use this formula to help you figure out the limit. So can anybody see what f of x is? ln. Just ln of x. Right? Don't plug the 2 in yet. Okay, so f of x is ln of x. And then absolutely, guys, what are we plugging in? A 2. So if this is the limit, then I don't want ln of 2. The limit is the definition of who? The derivative. So what is the derivative of f of x? Log. Dove, right. Remember a log, you picture a dove sitting on the log. So it's dove over of ln of the base. Okay, so dove, the derivative of your of, over your of, times down here, ln of the base, but what's your base? And ln of e is just 1. Okay, now, doesn't it make sense that the derivative of ln of x is 1 over x, because isn't the antiderivative of 1 over x ln of x? Okay, so 1 over x. Okay, now, what do I plug in? What number are they plugging in for x? Y'all see it? Well, but he's part of the formula. But yes, very insignificant. Okay, do we feel good? Because that pops up a lot. Seeing that structure. Okay, what's next? 25. All right. The graph is shown above, which is true. Okay, let's look. The limit as x approaches 1, it says the function is headed to negative infinity. What? The limit, remember you can approach a limit from either side? So if I approach 1 from the left, where am I going? Negative infinity. If I approach 1 from the right, where am I going? that means that the limit of this function as f of x as x approaches 1 doesn't exist. Okay, so it's not approaching negative infinity. Now, if this was as x approaches 1 from the left, y'all remember that? That would be negative infinity. Okay. The limit as x approaches negative infinity. That means as we're headed this way, as x is getting smaller and smaller and smaller, are we headed, it says, to a plus and a minus 1. Where's that sucker headed? As x approaches negative infinity, I'm approaching the y value of a 0. Okay? As x approaches negative 2, negative 2 is not even on here. There's negative 2. Where are we headed? At negative 2? Not past negative 2, at negative 2. Isn't he just a smidge above 0? So I'm not headed to 0. Okay? As x approaches positive infinity, so my x's are headed this way. Where is my function headed? The y value is headed to a 0, absolutely. So I'm digging number D. Okay, what about this guy? As x approaches 0, it says that my function is headed to infinity. Here I am approaching 0. Am I approaching infinity? No, where am I headed? What is the y value? The y value, negative 2. So you guys got to, so it can't be him. The point is, when you do the limit, this is what x you're approaching, and the result is what is the y value the function is approaching. Make sense? Okay, what's next? 26. Okay, do y'all remember removable, discontinuity, and jumps? I said think about it like a video game and he's got to jump. Removable just means that there's a piece missing, like a hole. It's not an asymptote. It's just a hole in the graph. Okay, it says a function f of x equals that for all x's except 1. Why not 1? You'd have a 0 on the bottom. The whole world would end. For the function to be continuous at 1, the value of f of 1 must be. Now, continuous means it flows. There are no holes. There are no asymptotes. There's no hiccups in there at all. Nothing gets disturbed. It's like fluid. So for the function to be continuous at 1, so we're saying it's going to have a hole at 1. So now I'm saying, okay, what would you need to plug in to fill that hole? Where is that hole? Do you guys see that you can GCF an x out of the top? If I GCF an x out of the top, these cancel. That's how you know it's a hole and not an asymptote or jump. If they cancel, it's a removable hole. Okay, what are we left with? X. What do I need x to equal? Where's the hole? So what does this side of the equation need to be so that it equals 1? Okay, good job. But here's what that would look like if it had some more meat on it, like if you were, I don't know, x plus 2, x minus 1. No, let's go x plus 5. And then these canceled. So what would you have left? X plus 5, and you need him to equal what? So then x would be negative 4. You see how that works? Okay, cool. What's next? Oh, okay. So go to test 2, which is what color? Pink. Yeah, it's bright. I'll wake you up. Okay, all right, here we go. Number 1. I want the limit as x approaches 2. Do bad things happen to this graph when x approaches 2? Okay, so what do you think? I think this is not permitted. Calculators are not permitted. Could you factor? Squares? No. No, 2's not a square. You can factor the bottom, but then nothing's going to cancel with the top. Can you? Yeah, that would just make it x squared minus 4. That's actually what the answer is. Non-existent. Okay, well, okay, think about asymptotes. How do you find vertical asymptotes? Bottom equal to 0 and solve it. Okay, so if you were to set that bottom equal to 0 and solve it, what would you get? Plus or minus 2, right? Okay, so that means I have a vertical asymptote. Hello. At plus and minus 2. Now, I want to know what this limit is as we approach 2. Guys, if there's an asymptote there, what's happening? It's never going to get to 2, agree? Now, do you remember like you could have graphs that sort of do that? We called them kissing graphs because they sort of come up together. Or you could have one that does this and one that does this, and they go in opposite directions. Either way, the limit as we approach 2, this is headed up towards infinity. If they're split, one's headed to positive infinity and one's headed to negative infinity. Look at your choices. Y'all see it? Okay, so if you'll look at your formula sheet, that's why I put asymptote rules on there. Yes, ma'am. You'd have to figure out if it's headed to positive infinity or to negative infinity. But yeah, if it's only approaching from one side, that's a whole new ballgame. But I'll tell you what, in going through these tests, I don't see a lot of right and left. It's a lot of both sides. Okay, number 2. Okay. Now, we're going to infinity. I have square roots on the top and the bottom. So if I eliminate everything else and just look at the square root of x over the negative 3 square root of x, and they both go to infinity, I've got infinity over infinity, right? Like there was one where the top or the bottom got bigger faster, and that's how we knew it was headed to 0. These are both headed to infinity at the square root of x pace. That they're equal. Well, there was a guy who had a rule. Little Hopital. It's La Hopital. Lol, like Lil Wayne. La Hopital. All right. Now look on your formula sheet and find La Hopital's rule. Do you see him bottom right? So if I have the limit, and I don't care where we're headed, but if I have the limit of something that I can't find, in other words, you have a 0 over 0, or you have infinity over infinity, one's not getting bigger faster than the other one, then I can use La Hopital's rule. This rule was really cool. It's the derivative of the top over the derivative of the bottom. It is not, I'm not going quotient rule on this thing. I'm not going low-de high, high-de low over low-low. I'm not doing that. It's straight top over bottom. Do what? Rewrite this guy with powers so we can go derivative on him. Okay. Derivative, not antiderivative. Derivative. Take your power, kick him out front, and then subtract 1 from your power. Okay, so what do we got? 1/2 x to the negative 1/2. And the derivative of a constant is 0. It's gone. Over. Okay, so the 4 is gone. So pull your 1/2 down front. But you've got that negative 3. So what does that give you? Negative 3 over 2. X to the negative 1/2. Now, what L'Hopital says is now I can retry my limit. But before that, can I clean this up at all? What happens to your x's? Don't they cancel? They're the exact same. I mean, I could move this one up, this one down, and then cancel them, but the point is they cancel. So I have 1/2 over negative 3 over 2. Go Bojangles on that sucker. And you're going to get a negative 1/3. Which is a constant. So I don't care where you are and what your limit's approaching, it's going to be a negative 1/3. L'Hopital makes lots of appearances on these tests, so be familiar with him. All right, where are we going? 9. Okay. Now, this you probably don't remember. You were really good at it once upon a time. If I plug in a 0 for my h, what happens? The bottom goes, yeah, I have a 0 on the bottom. Okay, so I'm going to multiply by the conjugate of the top. It was some good stuff. Some good algebra. All right, so here we go. Okay, what's root of cow times root of cow? Okay, so 25 plus h. These are conjugates, so the outside and the inside cancel. But then in the back, I've got a minus 25. So can everybody see that the top is going to go to h? Okay, now the bottom, don't distribute him because this little guy right here is going to cancel with the h that's left on top. So I'm going to leave him out front and put the conjugate in parentheses. Okay, now the 25s on top cancel first. Then the h that's on top cancels with the h that's on the bottom. So here's where I'm sitting. Remember, I'm taking the limit as h approaches what? I couldn't do it here because it made the bottom 0. Can I shove a 0 in there? Square root of 25 is 5. 5 plus 5 is, what's your answer? Nice. Where to? 24. Okay, 24 has to do with continuity, something being discontinuous. This is a piecewise function. It has 3 pieces. So I'm an x squared for all my x's that are less than 2. I'm a 4 if x is in between a negative 2 and a 1, but do you guys notice that there's no equal to on the negative 2? So what does that mean? There's a big old hole there no matter what. No matter what these functions are, these 2 functions up here are not going to connect. Even if they meet up, there's going to be a hole there because no x is ever going to be a negative 2. then I get to be this guy for all x's that are greater than 1, but remember, he gets to equal 1. So they may connect. I don't know. I have to plug it in and see. Okay, it says f is discontinuous only at -2. Do we agree that we're discontinuous at -2? Okay, so I'm going to give him a check mark. And if all the others are false, I'm going to go with him. F is discontinuous at 1. How do I figure that out? Can I plug 1 in and just see where they are? And if they're at the same spot, then I know they meet up. If they're at different spots, I know they don't meet up. So plug a 1 in here. I mean, he's a 4 no matter what. Plug a 1 in here, what do you get? He's a 5. So at 1, he's at 4, and at 1, he's at 5. Are they connecting? Therefore, we are discontinuous because they don't connect. So I like that one. It says C, if f of -2 is defined to be 4, then f will be continuous everywhere. What they're trying to do is say, okay, I see the fact that these two aren't going to connect. So if I define that at f of -2, we're going to be a 4, would that solve this problem? Yes. But would we be continuous everywhere? No. He's out. And then D just says, I'm going to stick my head in the sand and pretend we're continuous everywhere. No. So E says f is discontinuous at -2 and at 1, which is true. All right, what's next? Next test. All right, so we get off of pink. Get to give your eyes a break. What color are we now? We're gold. Golden. That's not yellow. Yellow's coming. That's gold. Okay, so we're number 1 and number 2. Okay, number 1. Oh, do y'all remember that? Yes, ma'am. He had, that's how he looks when I typed him. That's your step function. It's also called the greatest integer function because it trumps everything down to the greatest integer that's in it. So like 1.2 would trump to 1. 1.9 would trump to 1. 2 gets a step at 2. 2.1 would be a 2. It creates these steps. Now, what does it want? It wants the limit as we approach 2. Okay, for all of these numbers in between 1 and 2, what is that going to trump to? 1. So all of these numbers are here. But as soon as I hit 2, he goes up to 2. Then all the numbers in between 2 and 3 trump to 2. So as I approach x, and remember, this is not a right hand or a left hand, this is a as you approach x from both sides. It wants to know what the limit is. Doesn't exist. It doesn't exist coming from two sides because the limit as we approach 2 from this one is headed to what y value? 1. And as we approach 2 from this side, what y value are we headed towards? A 2. Does not exist. Now, you put a from the right, I got you. You put a from the left, I can handle that. But step functions are not continuous at integers from both sides. Okay, number dos. What's the problem with shoving a 0 in here? 0 on the bottom. Okay, who's our guy? L'Hopital. We really should look that up, make sure we're saying it right. We're good. Can we Stokes County that up a little bit? L'Hopital? L'Hopitoads. L'Hopitoad. Okay, so we're going to use L'Hopitoad. All right, so go derivative of the top. I think he was something in pre-cal. Yeah. We'll do the derivative and we'll see if it rings a bell. This is U substitution. Or you could do chain rule. I mean, chain rule is basically the same thing. So what is the derivative of sine? Cosine? Plain old cosine, right? Because we're headed this way. Okay, so cosine of all of that times the derivative of the inside part. That's the chain rule, the inside. So, well, the pi over 2, that's a constant. So what's the derivative of that? 0. What's the derivative of h? 1. So technically, I'm multiplying him by a 1. Okay, and then minus 1, well, the derivative of that is what? 0. Casey, you with me, babe? Over, what's the derivative of h? Good. So I have cosine pi over 2 plus h. That's it. That's all I have left. That's what L'Asymptote has gotten us to. Now, where's my h going? Can I plug a 0 in here? Okay, so the h is gone because it went to 0. So now I'm cosine of pi over 2. That's north. Cosine of north. 0. All right, where to? 17. 17. Which are we on this one? Okay. 17. What are y'all doing? Sort of loses the manliness of making a fist when your bracelet falls off. Sorry. Okay, number 17. For years to come. I hope it's like years. Oh, next year's? Oh, yeah, absolutely. Okay, let's pretend we're not 12. Here we go. Number 17. Suppose that function, if x doesn't equal 0, and then they're saying, okay, when x is 0, we're saying we're going to plug it at a 1. Which of the following statements are true? F is defined at x equals 0. Did they swoop in and save the day? Yeah, they defined it. They defined it right here. So we're good there. The limit as x approaches 0 exists. Now, I know that at 0 we don't exist, but I'm just wondering if we headed to the same place from both sides. Does anybody see any algebra we could do? Can we take an x out? Okay. Now, what cancels? The x, the guy that's giving us the 0, right? When they cancel, that's not asymptote, that's whole. Remember that? When it cancels, that's a whole. So because it's not an asymptote, it's just a whole, that means I'm headed to the same place. I just don't exist right there. Y'all with me? Okay, so yeah, absolutely. Now, they plugged the hole. Did they plug the hole at the right place? Because, sometimes you'll have a graph that's, cruising right along and it's got a hole in it and they'll plug it like down here. So I want to know, did they plug it on the graph? Well, they're saying that f of 0 equals 1. So x is 0 Y is 1. Plug it into what's left. If I plug in a 0 for X, do I get a 1 back? How are we doing? Okay. What's next? 20. Oh, with the part, and the 1 is true, and the, yeah, I know. All right. What are we thinking? I'm headed to 3. Do bad things happen at 3? Okay. Can you factor? What would you be left with? Okay. So what came out? Yeah, if you have x plus 3 over x plus 3, x minus 3. The x plus 3 came out, so what hole did we just cross out? At negative 3, right? Because it's an x plus 3. Okay, well, that wasn't what I was interested in. I'm interested in the 3. So this is what I'm left with. I'm headed to 3. Is it a hole? How do you find a vertical asymptote? Set the bottom equal to 0 and solve it. If I set the bottom equal to 0 and solve it, what do you have? X equals what? So you have an asymptote at 3. So it doesn't exist. $27. I must say, this is going faster than I thought. Are we doing good? Nice. We're doing good. 20 what? No, don't look. Don't do that. Don't. I know, it's not our problem today. Uh-huh. All right, 27. Where are we headed? Is that an infinity? Okay, as we are right now, your highest power on the top is a what? X squared. Your highest power on the bottom is a 2. So I'm headed to infinity equally fast. Okay, so what are we going to do? Who's our buddy? Little hoppy toad. Okay, now when you do this, guys, you really just need to focus on the ones that have the highest power. Because if you keep taking derivatives, all the lower guys are going to end up going to 0, right? When you derivatize them. So I'm really just interested in that over that. Oh, I lost my square. Now, hold on a second. What happens? Like right here. I haven't hoppy-toaded anything. X squared's cancel, and what do you have? Done. Okay, now let's say you don't see that. I'm going L'Hopital. Here I go. Negative 4x over 8x, right? I'm headed to infinity. Is that okay? He's headed to infinity, and so is he. That's bad, right? Okay, go again. Take the derivative. Negative 4 over 8, which is a negative 1/2. So you'll still get there if you don't see that it can just cancel. The point is, find your highest powers. They're the guys that matter. Okay, hold on. I got a what if. What if your powers weren't the same? Bottom's getting bigger faster, so you're headed to 0. Okay? What if the top was faster? Headed to infinity. The negative 2 in the front. Would that make it negative infinity? All right. Okay, are we on to Princeton?
Yeah.
Princeton's baby blue?
Yeah.
What number? 2? Okay, now Princeton's work, I think, looks more like what the actual AP test is going to look like. Do you see how they're much more spread out? Okay, so number 2, what is that going to? I can't read that. I think it's supposed to be an X. God, again. Hey. Oh. Come back. Baby, come back. There we go. Okay, let's try this again. I'm going blue. Okay. I think it's that. Is it infinity? Yeah, I think their math key strike just did the not equal to instead of the arrow. Okay, headed to infinity. Who do you focus on? Your powers. Okay, so I have a 5x squared over a 4x squared. What happens? They're going to cancel and leave you with done. And you can L'Hopital your way out of that problem too. And you'll still get 5 over 4. Number 4. That's me counting how many.
Oh, and then why do you have these circles?
Because they're good ones. But we're still going to do them. Okay. Oh, yeah, this is a good one. Okay, you got your formula sheet? Get your formula sheet. Go down there to where it's got limits. Okay, look, as of right now, if I were to plug in a 0 in here, isn't the bottom going to make the world stop turning? Yeah. Okay, so that's bad. What do you see on your formula sheet that looks like it could, with some tweaking, apply to this problem? Not infinity, 0. Equals. Okay. The point is that that and that.
Pardon this interruption, but at this time the track team needs to be dismissed to the bus parking lot.
All right, so the point is that your of on top and your guy on the bottom have to be the same. And if you'll look on your formula sheet, do you also see it flipped? X over sine of X still goes to 1. So just know that this guy can be flipped. You can also jack up his powers. Okay, so how do I not have this? Okay, so my X is being squared on top and it's not on the bottom. So I need an X down there on the bottom. So I'm going to multiply. I can only multiply by quantities of 1. That's what makes it legal. So if I need an X on the bottom, I need to multiply by X over X, right? Okay, the point is so I'm going to multiply, but this X on top, I'm going to kind of leave him outside. So now I have sine of X squared over X squared. Everybody see what I did? I multiplied by X over X, but the X on top I didn't need, so I kept him outside. Okay, so now what happens to inside the brackets? That goes to 1 times the little X that you left outside. So what do you have? I have an X. Now redo your limit. As we approach 0, all I have is an X. X is headed to 0. But I couldn't do that from the get-go because I had an X on the bottom, which made the world stop turning. So just make sure that those limits are back on your radar. Okay? All right, what's next? 14. Okay, this problem has nothing to do with limits whatsoever. But he doesn't fit in calculus anywhere. This is pre-cal. But he was easy, so I throw him in with limits because I have a feeling things are going to get not easy in the coming days. Fundamental period of a sine graph. What is the period? How do you find what is a period?
Yeah, like one full turn of the unit circle or whatever.
What? Think about it rolled out on the graph. It's one wave. Okay. What's a normal period for sine? 2 pi, because that's one lap around the circle, right? Okay, but when you put crap in it, and this guy's got a lot of crap, if you put stuff in here, it affects the period. The question is, which number affects the period, and how does it affect the period? Coefficient of who? Oh, that's your amplitude. It is the of. Which part of the of? Because some of the of does a shift. It is the pi over 4. It's the coefficient of the x in the of. Okay, so if you'll think back to pre-cal. Bx plus c. This was your amp. This told you how high it went. Your period is 2 pi, what it normally is, over b. No? Maybe? Doesn't ring a bell? Cosine's the same way. Tangent and cotangent, it was pi over b because they repeated faster. Okay, so the normal period is 2 pi, and it's 2 pi over b. Your b is the guy that's in your of and on the x. So if you were to distribute this out, wouldn't that be pi over 4? So 2 pi over 4. Everybody writing? Okay, Bojangles that. What's going to happen? Pi's are going to cancel. And I'm going to have a 2 times 4, which gives me 8. Bless you. Oh. Totally overshot that one. Oh, yeah, this is a good one. These are going to, Princeton really likes these. Okay, do we know what continuous means? Okay, and when you have a piecewise function, where does the action happen? Like, where do we need to be concerned? Where are they chopped? At 2. So I need to know if they connect. How do I find out if they connect? Plug a 2 in and see where they each are, and that'll tell me if they connect. Okay, so plug a 2 into the top one. What do you got? A 9. Plug a 2 into the bottom one. 9. So they are 2 separate functions, but at 2, aren't they both at 9? Okay, so they are continuous. Okay, differentiable. Now, I had forgotten this. I had to go back and look this up. Differentiable means that equals that of the other guy. This is the upstairs one. This is the downstairs one. The derivatives have to be the same at 2 for it to be differentiable. And that pops up a lot. Okay, so what's the derivative of the top? 2x. What's the derivative of the bottom? 7. Now plug 2's in. What do you get? 4. Plug a 2 in there. What do you get? 7. So is it differentiable everywhere? No, because their derivatives at that place are not the same. F of x has a local min at 2. I just have an X on that one. Okay, but look at your multiple choice. We know 1 is true, right? And we know 2 is false. We don't have a 1 in 3 options. Who's it got to be? Love some multiple choice. Okay, what's next? That goes into curve sketching. 23. Yet. Yep. Okay. Make sure everybody sees the 4 that's in the front. Everybody see the 4? Okay, we're approaching 0. Can I just shove a 0 in there? Because that'd be really nice. No, because the bottom. Okay. Yeah, can do a little hobby toad.
Pull a sign.
Can you hold on? Okay, can we pull a sign out? Let's pull a sign out. Remember, you got the 4. Don't lose the 4. Okay, now think. Look at maybe your formula sheet. Okay, so he looks like who? And something else. See it? The what? Okay, so check it out. Watch what I'm going to do. 4, chilling. Then I'm going to take this x squared, and I'm going to pull one of them and put it under that guy. And then I'm going to pull another one and put him over that guy, or under. Okay, so now I got my 4. What's the limit as x goes to 0 of sine of x over x? 1. Okay, now hold on. Is the third guy, is he right? He's both. Any backwards? Okay, so I'm going to throw a negative on my 4 sitting out front. And that's going to flip this guy to make him right. So what's the limit as he heads to 0? 0. 0 is okay. I mean, 0 is not like a limit can be 0. You just can't have zeros on denominators. So then I multiply negative 4 times 1 times 0. Done. $29. Oh, he's a good one. Good job, Hope. The big one. The original. He's the thing. Yes. Yes, he is. Okay, so he is this guy. Right? The limit as x approaches 0. And who is this? He is the derivative. Okay, so the question is, who's the original function? Who's f of x? Tangent of x. Now, what is it wanting me to plug in? Like, who's x? Pi over 6. Okay, but what have I not done yet? This is not f of x. This is the derivative of f of x. I need to find his derivative. Okay, can we remember this one? He is. He's secant squared. So now I found the derivative. So now I need secant squared of pi over 6. Okay, in your noggin, pi over 6. Is that ugly pretty or pretty ugly? Ugly, pretty. Secant is who flipped? Who's his? Cosine, right? So it's okay. So flip him, right? Because I'm not cosine, I'm secant. And square him. Right? Because it's secant squared. So what do you got? Do y'all see how you have to be on your toes and recognize that big old... You did. Well, but you know, secant and tangent are related in several ways, actually. A little Pythagorean, they're related.
Yeah, that's what I was saying.
Okay, now what? That was 29.
Yeah, 35.
35. Are you sure?
Yeah. No, I thought I was looking for 59 again, and then I realized I just got really confused.
It's all good. 35. We'll spread the love of that job throughout the rest of the days. You won't always be stuck. Oh God. That's it. We're done. Number 2. That's it. Okay, number 35. What happens if I just straight up plug in a 0? World stops turning. Okay, does this look like anything? Like, I'm not seeing it either. What? So who's our guy? Okay, let's use the guy. Okay. Oh, now we're about to take the derivative of 3 to the something. Okay, so the derivative of 3 to the something is 3 to the something times the derivative of the up times ln of the base. Now remember that when they're e's, it's like crazy easy. But when it's this, you've got that extra ln. We're going to have an extra ln of 3 on the end. Okay, so 3 sine x, so leave it alone, times the derivative of the power, derivative of sine, cosine, plane, right? Times ln of the base, which is 3. Then minus, what's the derivative of 1? So he's gone. Over, what's the derivative of x? 1. So we're here. Okay, now I can plug in a 0. The world's not going to stop turning, so let's plug in a 0. So I have 3 to the sine of 0 times cosine of 0 times ln of 3. What's sine of 0? 0's over here. Sine of 0. Sine is your y value. So he's a 0. So this is 3 to the 0. Right? Because that's your power. What is cosine of 0? 1. And then ln of 3. Okay, well, what's 3 to the 0? 1. And 1 times ln of 3. Good job, good job. 43. Oh, God. 40. I mean, yay, 43.
No complaint.
That's what I meant to say. Yay, 43. Now, I remember when I taught you guys this, because this involves a system. And when I taught this, y'all were like, yep, got it. Yep, you got to the test, over half of you missed it. Like, nope, don't have it. Okay, if the function, we're going to get it. It's there. If the function is differentiable, and that gives you f of x, then I'm looking for a. Guys, we got a's, we got b's, and we got x's. What did I say earlier about differentiable? Who? Their derivatives have to equal each other at that spot. Right? Okay. Now, if it's differentiable, it also has to be continuous. It's assuming that it's continuous. Well, guys, if I'm continuous, what has to be true about those two suckers? They have to equal each other at 1. You just made your system. Okay? So let's do continuous first. Continuous just means that this guy must equal this guy at 1. So when x is 1, so plug in some 1s. So if I plug in a 1 for x, that's going to give me a minus 6 equals b plus 4. Got rid of my x's. Okay, now I want you to take this and I want you to clean it up and make it look like math 1. Okay, math 1 would say I want my a in the front, and then I want my b, and then I want my equals, and then I want my constant over here. So A is going to stay put. I'm going to subtract the B to the front, and I'm going to add my 6 to the back. It just sort of puts them in this nice standard form. Okay, so that's the continuous part. Ready to go. All right, now let's go differentiable. Differentiable is derivatives. So give me the derivative. 3a, because a is a constant, x squared, good, minus 6. Are y'all okay with that? Equals, now go other side. Right? Okay, but all this has to happen where? At 1. So shove a 1 in for your x's. So 3a minus 6 equals 2b. Okay, now make that guy look like he's everybody in the right spot. So who needs to move? Okay, so I'm going to subtract my 2b over, and I'm going to add my 6 over. Now, back in the day, y'all could get to here. This is where you put the 2 together, and you make a system. So look at those 2 together, and we're going to do a system. We're going to do elimination. We're going to try to get somebody to cancel. Who is it asking for, A or B? A. If it's asking for A, who should I get to cancel? B. Okay, how can you get B's to cancel? Who do you need to multiply by what? Negative 2. Because the signs need to be different. That's what makes them cancel. Okay, so I've got a negative 2a plus a 2b equals a negative 20 with a 3a and a minus 2b and a 6. Do y'all remember this? Was this guy in there? I don't know. I don't remember. The b's cancel, which was the whole point of what we were doing. Then a negative 2a and a positive 3a gives me a equals, negative 14. You can do it. Okay, is everybody crystal clear on what differentiable means? Okay. Where are we headed, Captain? Oh, Princeton 2? Yeah. Number dos. Wait, that's not, is that Princeton 3? What? Who is this? Oh, that's practice test 1. What the world? There's 3. Restarted what?
We were on 45 and it did this. And then,
Yeah, because those are free response, babies.
Okay.
Yeah.
You're breaking my neck.
The free response questions come after the multiple choice. Okay, I don't have Princeton 2. I don't have him scanned in. How many problems were there? Oh, there were some good ones too. Let's go to Princeton 3. And let's do those. And if I have time, Princeton 3 is peach. Peach. All right, look at number 6. Does he look like he could be something? But do y'all see how you need to go there? Like you need to go there and you need to think through it, but no, I can't I have two terms on the top, one term on the bottom. I can't GCF out of the top. And all of the limits we're supposed to have memorized with sine are all single-termed things. This is two terms, and I can't do anything about it. Now, if we were cosine, that's a different story, because his is two terms. Although I still don't think you could do anything with this. Okay, so the point is I can't use that. So, who's our guy? Here we go. Go derivative of the top. 1 cosine over 2x. Still can't, can I? That's the cool thing about L'Hopital. You can go again. I can't plug a 0 in here. It would still make the bottom 0. Okay, so derivative of the 1, gone. Derivative of negative cosine, positive sine. Because derivative of cosine would be a negative sine. So positive sine over 2. Well, can I plug a 0 in here? Okay, so 0, what's sine of 0? 0 over 2. It's a lot of work just to get a 0.
Yeah, that's what I was thinking. Maybe you could do it as 1.
Pull out a 1/2. And then use the, is he 0? And then 0 times 1/2? Yeah, that would work.
That's where I thought we were going.
No, I was just going to L'Hopital all the way out. Okay, so once we did L'Hopital once and got here, this is really close to the one on your formula sheet.
Oh.
He's got a 2, so you just have to, Okay, where? 13. 13. Oh, yeah. Don't do that. Oh. Siri. Easy, Siri. 13. Okay, we are differentiable. Ready? All right, let's do this. Let's rock this one like we know what we're doing. Okay, let's be continuous first. Continuous means the original functions are equal to each other at 1. So now go shove in a 1 for all your x's. Okay, now I mildly panicked when I first did this problem. I was like, oh, he's got extra stuff, but he doesn't. If you clean him up, he cleans up just like the other guy. Subtract your A over, add your 4B over, and then subtract your 1 to the other side. Cleans up just as good as the other guys. Okay, now what? We're going to the differential part, which is the derivative. Okay, go. 6ax plus 2b, and the 1 is gone, right? Equals 4ax cubed minus 8bx minus 3. At, so shove a 1 in there. Okay, clean them up, make them look good. Okay, now I'm going to put them together. And I'm writing out all my steps. You guys are going to get so good at this that you'll be able to skip some steps. Maybe. Who do I want? So who should I get to cancel? What do they need? Yeah, pick one of your equations. It doesn't matter which one, and just run through with a negative. I got a 4th. Sorry, spoiled the surprise. Hey, good job. All right. Okay, now we're headed down the page to number 15. Oh, he's a good one. Okay, does he look like anything? A hot mess. Okay, where are we headed? I can't read that. Is that infinity? Okay, so I've got infinity on the top, infinity on the bottom. That's bad. Who do we swoop in to save the day? La Hoppy Toad. Okay, we got to remember how to take the derivatives of logs. What is sitting on the log? The dove. Okay, so dove over of. So dove is the derivative of the inside over the of, technically times on the bottom ln of the base, but ln of this base is ln of e, which is 1, so we don't have to go there. Now that's the top. The bottom, dove over of. So dove, derivative of your of, over your of, and then in the bottom times ln of 2, ln of your base. That one doesn't go away because he's not an e. Okay, Bojangles. Okay, shove infinity in here. What happens? I still get infinity over infinity. We got to go around too. Okay, now guys on top. This is great. Derivative rules. Technically, ln of 2 is a constant. Do y'all see that? So what's the derivative of x times ln of 2?
No, just ln of 2.
So what's the derivative of 5x? Just a 5, right? Now, if you don't notice that, and honestly, guys, the first time I did it, I did product rule. And I still got ln of 2. But what's the derivative of 5x? 5. So what's the derivative of ln of 2 times x? ln of 2.
I was thinking next thing there was two, so I was like,
Yeah, I was like 0 times.
The derivative. And then what's the derivative of the crap on the bottom? A 1. So do I care where we're headed? Like, do I have anywhere to shove infinity into? I will always be ln of 2. 24. No. Nope.
can I take Sarah real quick?
Yep.
Who's doing this?
You gonna tell her to say something about the police company? So you definitely don't put your head on.
Oh.
What better something? 5 kids?
Okay, guys, here we go. What happens if you plug in a 0? What's now? See, sometimes when you have trig on the bottom, that's not guaranteed to be a 0. But what's sine of 0? Okay, but if that was a cosine, we'd be okay. But it's a sine, so this is bad. Oh. He looks like something. Look. Could you not have a tangent? Can we make him sine over cosine? Okay, let's start there. Write small. I know. Yeah. Okay. Can I pull this thing apart? See how the whole thing's over sine of 5x? Can I make them two separate islands? Okay, so here's what I'm going to do. I'm going to have sine of 3x over cosine of 3x over sine of 5x, island, plus 3x over sine of 5x. Okay, if you are to Bojangles this guy on the bottom, wouldn't that give me that times that? Y'all with me? Okay, I'm just going to live right here on this island for a while. I'm going to be in denial about him. Okay, let's just clean up the first island. What on your formula sheet are we close? Sine of AX over sine of BX. Okay, but I've got like mismatched socks on. We gotta switch this stuff around. So I really want this over him because they're both sines. And I'm gonna let this guy come out here. Are y'all with me? I'm trying to build it so it fits. Okay, so what does the first fraction go to? 3/5. Okay, well the problem with this whole mess was that I had a sign on the bottom and I can't sign 0. Guys, if I go to 0 and I plug a 0 in for this guy, can I cosine of 0? What's cosine of 0? So this island is a 3/5. Done with that island. Okay. Now let's talk this guy. He is almost that first limit on your formula sheet. But the flipped one, my of is a 5x. I can't change my of. So I don't really want the 3 right here. I really want a 5 right here. So can I do that? Can I multiply by 5 over 5? And then can I take the 3 and the 5 and switch them? Oh, but we did this. So watch. I want, I'm looking for this because that's on my formula sheet. I need this guy and this guy to be the same. I can't change my of. He's locked in. So I want a 5 right there. So I'm going to multiply by 5 over 5. He's extra. He's chilling. I'm going to pull the 3 out and let him chill and put the 5 in. It's all multiplication. I mean, I can write it any order I want to. So this becomes this. Look. Y'all see what I did? Right? Right?
It makes sense. I'm just like, it's not the same.
So what is this? What's that? 1 times, so, and there was a plus sign here, right? And 3/5 plus 3/5 is 6/5. It's doable. Is there one more? 45. All right, go 45. Am I on the right one? No, 39. Go 39. Okay, he should look like something. He looks like the big hunk up thing. Okay, what's your f of x? Yep, sine of x. So what's f prime? Cosine of x. Okay, so cosine of what? What are you plugging in? 5 pi over 6. So all I need to know is what's cosine of 5 pi over 6. Okay, go unit circle. 5 pi over 6 is going to be a 6 short. So he's ugly pretty. I'm cosine, so I'm ugly. Negative. God, it's negative. Everybody see it's negative? Okay, hold on. Don't move. What is he doing? Like, I thought it was... Why is that not f of x? F of x is sine, right? Sine of 5 pi over 6 is 1/2. They just already cleaned that up to mess with you. That's it. That's it.